This is video 47 on a Home Assistant and embedded solution. If you already have a Home Assistant, then this video could help you. If not, then you may want to build a Home Assistant system. Last week, we introduced ESPHome for a Pico W system. In this video, we learn how to start using LVGL graphics on an ESP32-S3 microcontroller that is controlled by Home Assistant. So this discussion will sound familiar. There will also be new information for the ESP32. Please let us know in the comments about your home automation system. We welcome ideas. Our test rig is based on an ESP32-S3-DevKitC-1 USB board connected to an ILI9341 display. Our board has 8 megabytes of PS RAM. For this effort, we assume you have Home Assistant running. We deployed the latest 2025-07 Home Assistant on a Raspberry Pi 4 single-board computer. We have a minimal implementation that includes the ESPHome Device add-on. We did this by following the install instructions on the Home Assistant ESPHome Device Builder page. At the ESPHome documentation, there is more information to help you connect. We include a link in the description and in the endnotes for this video. As this channel covers multiple small system solutions over time, please subscribe to stay informed and click like, as that really helps. Our goal is to first deploy a minimal configuration that displays a few LVGL widgets and verifies the touchscreen. Then we'll expand it a little bit to add a few features. So, in this video, we will demonstrate a few ESPHome Cookbook LVGL examples during the demonstration time. We'll present the test rig wiring. We'll walk through a simple LVGL configuration, and then we'll expand it. The YAML files for this are at the GitHub site that is mentioned in the description and endnotes for this video. This first example is called an LVGL meter in the ESPHome system. You can see that I've modified it from the Pico W to use the internal temperature of the ESP32 device. This is the second example. You can see we've compiled it and it's running. This example is showing LVGL graphics using a flex layout. Additionally, each button, instead of having text, has an icon. You'll notice there are the 3 widgets. At the top we have the switch, which has this orange knob. In the middle we have a label that says Hello World. And at the bottom we have a slider. Preparing your Home Assistant system for LVGL graphics begins with the ESPHome add-ons. It's easy. You click on the Add-on Store button and search for ESPHome and add it. You can see in our system we've already added the ESPHome Device Builder. But if you haven't, you would click on it and that would add it in, and it would show up on your add-ons page, as mine does. One of the options is to add it into the side panel, which is very convenient, so I've done so. You'll see a new menu item called ESPHome Builder appear. Here we can add a microcontroller with a display in 3 steps. First, we connect the display to the microcontroller using wires. Next, we add and define the device in the ESPHome Builder. Finally, we install the device from the builder. To do the wiring, we look at a pinout diagram of our device and choose the pins to wire. Generally, we can use almost any pin, but some pins have special functions. In the diagram, we've highlighted the serial peripheral interface communication pins, aka SPI. TFT displays like the ILI9341 prefer to communicate using the SPI protocol and several control pins. The SPI pins are often used in microcontroller projects and have common names. as I've shown on the slide. On this slide, we show the pins used in our test rig. The display and touchscreen pins can be different for your system. The display also needs to wire the ground and 3.3 volt power pins. The display's backlight pin, called LED, we simply wired to a 3.3 volt power pin. Back on Home Assistant, select the ESPHome Builder menu item. Here we can add our microcontroller device. As you can see, we have already added an ESP32 device called Central and a Raspberry Pi Pico device called Pico W. As we are interested in the setup of the Central in this video, let's click its Edit button. The YAML script describes a specific microcontroller. We can add Home Assistant automations and attachments, and of course define the pins for the display and touchscreen. Finally, we include our LVGL statements. By the way, we replaced keys and passwords with the Home Assistant secret keywords. Let's walk through it. The script begins with ESPHome and the name of the node. Next, we describe the node as being an ESP32-S3-DevKitC device. We also mentioned that it's got 8 megabytes of PS RAM. One of the features we want to see is logging, and so we've added a logger. Next, we've enabled the Home Assistant API. Next, we provide the over-the-air password. Then, the Wi-Fi connection to your home Wi-Fi system. Make sure to keep this secret. If you need, you can configure it using a manual IP. Next, we provide a fallback hotspot that hopefully you won't need to use. On the ESP32 devices, you must enable a web server. And you can choose to have it use authentication. Now we're getting into the part for the display. The first thing we need is SPI communication. So these are the pins that we talked about earlier for SPI. Next, we describe the display. In this case, it's an ILI9341, and we describe the control pins that it may need. You can see that I've set my display as in landscape mode. To use portrait mode, you would change the rotation to 0, but you would need to alter the touchscreen settings. For now, let's keep it on landscape. Let's move on to the touchscreen. So you could see that we've configured our touchscreen using the XPT2046 interface, which is what's on the 2.4-inch ILI9341 displays that I'm using. And we provided both a CS pin and an interrupt pin. Next, we provide some transformation statements. These will become important when we discuss them later. Finally, we have the LVGL statements. We tell it to use the above display and touchscreen, and then we've defined a label and a switch and a slider. The reason for this will be evident in a minute. Let's start the system. Once we've edited our configuration script, we need to compile it. In order to do that, we come back to the ESPHome Builder page. Here, we're going to look for the 3 dots in the lower right-hand corner and click on it. The first thing we'll see is Validate. We're going to want to click on that, which brings up a terminal. And this will start to verify the code. This will take a few minutes, so give it time. Okay, it shows that our configuration is valid. So let's close it. Go back to the 3 dots, open it up, and click on the Install. You have the choice to do a wireless or a manual download. If you have trouble loading the system wirelessly, then please use the manual download, and that will give you a bin file. But we're going to use the wireless connection. This will open up the terminal again, and this time the messages we get will be for the compilation of the script. This may take up to 5 minutes the very first time, depending on how big your host system is. So give it lots of time. As you can see, my system has already finished compiling, and it's going into the linking stage. In a few seconds, it's going to begin downloading this to the microcontroller. Okay, so it has downloaded the script to the microcontroller and has restarted it. You can see that it's connecting to the Wi-Fi by virtue of all the purple comments that you see next. At this point, we want to verify the touchscreen. So we can do that by watching the logs. Now that we know it's connected, we can take our stylus and touch the screen. When we do that, you'll see the touchscreen updates with its XY position with the raw coordinates on the log file. By studying this and moving your stylus across the screen, you can determine the maximum raw value in the X direction and the maximum raw value in the Y direction, and you can correct the calibration for your touchscreen. Once you've done this, you can stop this log and we can go back and we can go to the next step. You'll notice there are the three widgets. At the top we have the switch, which has this orange knob. In the middle we have a label that says Hello World, and at the bottom we have a slider. As I found it convenient to ensure that I had the proper calibration and the transformation statements on my touchscreen settings, that the transform for the touchscreen has a mirror X, a mirror Y, and a swap XY. If you take a stylus or your finger and move it across the touchscreen when you first bring it up, you're looking for it to interact correctly with the stylus. However, if it doesn't react when you touch the screen, then there could be issue, most likely with the transform statements. Either you have the mirror X or mirror Y backwards, and so you could set one true and the other false. Or if you find that the screen responds when you move diagonally across the screen, then you may have to swap the XY coordinates and set that to true. If we look at our configuration, that's exactly what I did. Now that you have the display and the touchscreen working, we can add more configuration items. Let's add an off-board LED and the onboard RGB light that are on the ESP32 device. To control them, we will add logic to the LVGL switch to turn on the LED and the light, and we will add an LVGL button to turn them off. Finally, we will add a switch to the Home Assistant screen to control the off-board LED from the Home Assistant system. Okay, we've added the changes to the YAML configuration for Central. We've compiled it and installed it on the microcontroller. You can see that we're running the logs and we've just connected to the system wirelessly. Let's walk through a demonstration of what the features do, then we'll look at the configuration code. There is a new widget on the display in the upper corner. And it's a button that says LED off. In the middle, you'll see the ESP32 device. And then down here, you'll see another board that has the external LED connected to it using these wires. Let's run the function. So we've configured the switch so that when we touch it and it switches on, it turns on the RGB LED and turns it green on the ESP32 device. And it's turned on this external LED on the extra board. Now I've done both of these so that in your system you may not have an external board that you can wire up to an LED, and you may only have this RGB LED. In that case, you can just remove the statements to configure the external LED. Or you may wish to add one and want to know how to do it. So I have both configurations in this example. Next, we have the button. When we press the button, it turns off the switch for both of the lights. So the light went off and the LED went off. But you'll notice that the touch occurred in the logs as well as the messages about the output being turned off. If we close the terminal, we can now walk through and review the additions to the configuration. So the changes began about halfway down. I have a section before the web server, and that's to split up the changes for the Home Assistant dashboards versus the changes for LVGL. So here I've placed definitions for the switch and the output and the light. So we have first the switch. We defined it as a platform output, and this switch will appear on the dashboard with the name generic output. Next, we integrated to the actual microcontroller by giving it a GPIO pin. Here it's GPIO pin 17. Notice it also has an ID, and the reason for multiple definitions will become clear in a minute. Now for the light, thanks to Bob29 and ARH through one of the forums, I found a good configuration for the ESP32-S3 device. The NeoPixel LED that's on the board, it uses this platform. The RGB order might be different on your USB board, so you'll have to adjust this to match what your system does. I'm using GPIO48, and here I've given it a name that will appear in the dashboard. Now let's scroll down to the LVGL changes. Here I've set the internal font as Montserrat 36. Here's the first change. To the switch, which did nothing before, we've added this action of on value. So if it gets a value, it's going to, and what do we want it to do? Well, we want it to turn on the lights. So you can see I use the output above to turn on the offboard LED. I use the switch to turn on the switch out. And this is to accommodate the dashboard. And finally, I have a light turn on for the NeoPixel light. And you can see here I could choose red, green, or blue, but I've chosen to use just the green color. We're not using the slider at the moment, but here's the new widget called Button. I've labeled it, I've given it the ID button off, and I've labeled it LED off. Here I'm using the Montserrat font 24. Finally, I'm giving it this action. On the click of the button, we are to turn off the SW out switch. Next, we're going to turn off the LVGL switch, and we must do that with an LVGL widget update. So here I've given it the switch ID for this above switch right here. And I've changed it to its state of checked to false. And finally, we turn off the onboard light. So notice that we're doing multiple actions in our on-click. So that's it. You've seen how it operates through the demo. Let's see what it looks like in the dashboard. So I've provided a dashboard for the lab, and here are the two outputs. Let's leave it there and go and turn on the switch on the LED. Okay, when I did, you'll see that it immediately turns on the outputs in the dashboard. So the dashboard reflects what I'm physically seeing occurring on the microcontroller. Now, if we press the LED off button, it's going to run all those actions. It went out and turned off each of the outputs, as well as turning off the physical lights. And there you have it. It was important to show a way that we can do things on the microcontroller via the LVGL display screen that integrate back in the Home Assistant dashboards. Hopefully seeing this example helps you configure your ESPHome device and start using beautiful LVGL graphics. In summary, in this video we demonstrated LVGL graphics. We presented the test rig wiring, and we walked through a simple hello world configuration that allowed us to verify the touchscreen, and then we added some additional features. The benefit of all this is simple, flexible configuration for our displays with our Home Assistant system. Please comment if you feel other changes are needed. I hope this video helps your Home Assistant ESPHome LVGL programming. Thank you for listening.